Good morning, everyone. Today we will have a lecture on estimating and engineering mechanics. So already in previous lectures we have discussed about the numericals related with the equilibrium. So we have seen that is UVL, uniformly varying load, and trapezoidal loading. In case of a simple beam, how to convert UVL into a point load, or how to convert trapezoidal loading into a point load. So already we have discussed in previous lectures. Again in today's lectures we will solve some more problems regarding engineering mechanics. So first of all, which things to be calculated? I am reading the problem. Find the reactions at support A and B. That means at support A and B, so support A is hinge support, support B is the roller support. So how many reactions which has to be calculated? So at A there will be 2 reactions, at B there will be 1 reaction. So overall there will be 3 reactions which is to be calculated in this problem. So find the reactions at support A and B. That means 3 reactions to be calculated in this problem number 5. Okay. Again, the special type of bracket loading is given. This type of loading is called as the bracket loading, in which there is a vertically downward force of 30 Newton which is acting on a bracket. This is nothing but a bracket. What it says, bracket is it is somewhat a it is having somewhat a smaller height, that is 0.5 meters, and it is having a width of 0.5 meters. That means a load, it is not directly acting on this beam. It is not this 30 Newton, it is not directly acting on a beam, but it is acting through a bracket on a beam. Okay, this load 30 Newton, it is acting through bracket on a beam. That means the bracket height is 0.5 and width is 0.5. So here in this pattern, this 30 Newton, it is been acting on a beam, indirect way of acting this 30 Newton on a beam. So how to convert this 30 Newton, or how to transfer this 30 Newton on this beam, it is very important concept. Okay, so or what is the criteria, or what is the effect of this 30 Newton when it is acting on a bracket? What is the effect of this 30 Newton on beam? What is the effect of this 30 Newton on a beam? So how to convert this? It is very important concept. So this 30 Newtons, in order to balance this 30 Newton, or in order to find out or in order to convert this 30 Newton into a couple, okay, this will form a couple because it is acting on a bracket. So here for simplifications, we are assuming original figure is this, but we are assuming for simplifications, we are assuming that this 30 Newtons, it has been balanced by these two forces which has been acting on this same at this point. That means I am drawing a separate figure for this. So suppose this bracket, it is same, I am drawing the same figure for this. Yes, this is 0.5 meters, this is 0.5 meters. Okay, what about this 30 Newton, it is acting at this point. Kilonewton, it is acting at this point. For simplifications, what is the effect of this on this beam? So I am drawing two forces. Suppose this force I am assuming as 30 newtons, kilonewtons, and this again I am drawing a force in vertically downward directions parallel to this as 30 kilonewtons. Just for simplifications I am doing this. Okay, that means this 30 kilonewton is the original force, but for simplifications I am assuming that I am drawing at this point I am drawing a vertically upward force as same intensity as 30 kilonewton, and downward force at the same point as 30 kilonewton. What is the effect of these two forces at this point? It is zero. What is the effect of these two forces at this point? It is zero, because upside force is plus 30, downward force is minus 30, plus minus is 0. But for simplifications I am assuming that at this point we are applying 30 kilonewton at upside force and 30 kilonewton at downward force. Okay, up to this point for simplifications just I am assuming, but there is no as such effect on this point, because upside is positive, downward is negative. So all this summation of these two forces will be 0, and this original force will be as it is, the original force. Okay, So there is no change in this original force, but for simplifications, upside and downside force I am applying at this point. Okay. Again, what is the effect for this? So this effect I am this downward force which I have assumed at this point. So I am in present case I am assuming this force is not acting. I am keeping a finger on this. Okay, so this force is not acting for present case, but these two forces, downward force of 30 kilonewtons and upside force of 30 kilonewton, these two forces they are producing a couple. The 30 kilonewton downward force and 30 kilonewton upside force, which is separated by a distance of 0.5 meters. That means these two forces, downward and upward force, will produce a movement, will produce a couple. What should be the intensity of that couple? So 30 into 0.5. So we will assume this as it is forming a couple, and its intensity is 30 into 0.5. So it will be 30 into 0.5 is 15 kilo Newton into meters, because it is multiplied with meters. Okay. So is that clear? These two forces, downward and upward force, will form a couple. It will form a couple having an intensity of 30 into distance. So distance is 0.5, which has been given in the question. 30 into 0.5. It is 15 kilonewton meters. But after drawing this, I am removing the finger from this. Original force was 30 kilonewtons, which is acting at this point. That means this force will be as it is transferred at this point. This force will be as it is transferred at this point. Okay? That means this 30 kilonewton will be at this same point, and these two forces will form a couple. So what this bracket it has been converted into, this 30 kilonewton bracket force, it has been converted into one couple, and the other downward force as 30 kilonewtons. One, it has been converted to couple, and the other as 30 kilonewton downward force. Is that clear to everyone? So I am drawing a figure for this. So that means the revised figure for this is after conversion of this. So this it is acting at this point. So we will draw after transferring to the figure. This will be drawn, and this will be acting as at this point, the same point as 30 kilonewton. Whereas beyond this, at this same point, there will form a couple. At the same point, there will be a couple. So this, and its intensity is 15 kilonewton meters. That means this bracket 30 kilonewton, it has been converted to vertically downward force of 30 kilonewtons, this force, and this couple, that is 15 kilonewton meters. So we'll draw a revised figure for this. Again, what about this 80 kilonewton per meters? It is UVL. Again, it is acting at CG. What should be the intensity for this 80 kilonewtons? So I am again writing down for triangular loading. So half into base into height. For triangular loading is the same case. Already we have discussed in previous lectures. Half into base is 3. And what about height in this case is 80. So after convergence, it comes to be 120 kilonewtons. So it comes to be 120 kilonewton. That means intensity of this 80, it is 120. And where it will be acting? It will be acting at this at this point. So I am drawing a figure for this. So this is the point at which it will be acting. This point. Yes. At this point. Okay. And its value is 120 kilo Newton. What about the distance? The distance is same. The smaller distance is 1/3 of length, and this is 2/3 of length. So I am writing down here as 2/3 of length, 1/3 of length. So what is 2/3 of 3? So this 2/3 of 3 is 2 meters. this distance is 2 meters, whereas this distance is 1 meters. So is that clear? So we'll draw a revised figure so that it should not be there should not be any confusion. We'll draw a revised figure for this, in which all these loadings will also be taken care. At the same point we are drawing the figure. Yes, I am transferring this vertically downward force of 30 kilonewton and a couple of 15 kilonewton at the same point. And this distance is same, but this distance and the original distance will be somewhat different. Final point. And this distance. Distances are very important. We have to mark the distances in a proper way. So these are the distances which we have taken. So this was the original distance as 2 meters. So we have at this point it is 2 meters. 1 meters is as it is. What about this distance? It is 2 meters. 3 meters it has been divided into 2 meters and 1 meters. And it has been converted into a point load at this point, which is having an intensity of 120 kilonewtons. Which is having an intensity of 120 kilonewtons. Okay. So this conversion of this bracket into a vertically downward force and couple, whereas conversion of this UBL into a single point load at this point. What about this hinge support? So hinge support will have two reactions. So we will draw two reactions, vertical reactions, vertical at A and horizontal at A. And at this point, vertical at B. So we have drawn a revised figure for this case. The revised figure, it has been drawn. So it is very important. Conversion of this bracket into a vertically downward force and couple. Conversion of this triangular load into a 120 kilonewton load. Okay. So this is the simplified figure for this. So now the calculations is to be carried out. So what are the different three conditions of equilibrium? So summation of fx is equals to 0, fy is equal to 0 and movement is equal to 0. So one by one we will use the conditions. So first I am using fx condition because there is only one horizontal force. So directly we can find out this value. Summation of fx is equals to 0. How many in x directions? So there is only one force. Okay. After calculations it is 0. So HA is equals to 0. That means first value, even though it is 0, we have to calculate. Y conditions we cannot find out in second Y because VA and VB there are two unknowns. So we will use the third conditions as summation of movement of all forces at A. Why we are taking at A? That is equals to 0. Moment of all forces at A is equals to 0. Why we are taking at A? Because A is hinge point and two forces are acting at point A. So therefore, all forces at A, that means HA will be 0, VA will be 0. What about this 30 kilonewton about A? So what is the distance for this? Clockwise 30 into 2, and it is clockwise, therefore positive. What about this 15? 15 is already a moment and couple. 15 kilonewton meter. It has been already multiplied with meters, so there is no extra multiplication of this 2 meters. So directly we will take this as plus 15. What about this 120? 120 it is separated by distance of 2 plus 2 plus 1, that is 5. Again it is clockwise, so plus 120 into 5. Okay, so 2 plus 2 4 plus 1 5 clockwise. last is minus VB into its distance. So 2 plus 2 4 and plus 2 6. With minus sign it is VB into 6. That is equated with 0. That is equated with 0. That is equated with 0. Okay. So what is the value of VB? VB we can take at right side. So VB value is vertical force at point B, that is equals to, so after calculations it comes to be VB value as vertical force, or at B point it comes to be 112.5. So you can calculate this value, kilo newtons. So this VB value is 112.5 kilo newtons. Now we can use the last condition of equilibrium as Fy is equals to 0. Now we can use the last conditions. Therefore VA is vertical force at A point, VB is vertical force, minus 30 is downward force, and minus 120 is again the downward force, that is equated with 0. VB, just now we have taken care 112.5, so put this value, and after simple cross VA vertical force at A, it comes to be 37.5 kilo newtons. So in this way we have solved the problem in which this bracket it has been converted to this revised figure, this UVL it has been converted to revised point load, and HA is 0, VB is 112.5, and VA vertical reaction side A is 37.5. Okay, next problem, problem number 6. Next problem is again important. Problem number 6 is again important. So find the reactions or find the reactions at the support A and B. Again the different support or the different conditions it has been given. So again we will find out the different conditions. So here A is the hinge support, B is the roller support, but there is an inclined force of 10 newtons, which is making an angle of 30 degrees with horizontal. UDL is also there, 3 Newton per meters. This UDL is acting over a span of 2 meters. So therefore we have to convert this into a point load. Here extra is the couple. In previous lectures we have converted bracket into a couple, but here directly a couple of 5 Newton meter it has been given. Newton meters it has been. So in other words it is a movement. It is a couple, in other words is nothing but it has been measured in Newton meters. So 5 Newton meter it has been directly given. So we will simplify, we will draw a simplified figure for this, and we will find out the reactions. Okay. So I am drawing a simplified figure for this. So here this 10 Newton it will be resolved into two components, vertical and horizontal components. So horizontal component will be cos theta, vertical component will be sin theta. So I am writing down here in the same figure as 10 cos of 30 and 10 sin of 30. Sin of 30 degrees. Again this 3 Newton per meters will be this conversion of UDL into point load. It will be acting at center. So I am again drawing the same figure for this. We will draw it at the center. Yes, will be acting at center. What should be the intensity for this? W into L. W into L. I am writing down W into L. That is load into distance. So load is 3 and distance is 2. That means it is converted to 5 Newton. Sorry, 6. 3 2s are 6 Newtons. 6 Newtons. 3 2s are 6. Where it will be acting? So it will be acting at center. That means 1 meters, and at left side it is 1 meters. At right side that is 1 meters. Now need to convert this couple, and at this A point there will be 2 reactions. At B point there will be 1 reactions. Okay. So I am drawing a revised figure for this, in which the calculations will be more easy. So at the same point we will draw the figure. These are the distances for this. So this distance I will mark here. The distance will be marked here. It is converted to point load, and here is the distance for couple, and finally the this, and this it has been made for the actual figure. This line it is for actual figures. So at this point there is two forces are acting. This force is 10 sine of 30 degrees, 10 sine of 30 degrees, and at this point it is 10 cos of 30 degrees. Vertically downward force after conversion of UDL into a point load, its intensity is 6 Newton. Where it will be acting? So it will be acting at a distance of 1 and 1 meters. At this distance will be 1 meters, and this distance will also be 1 meters. Okay, this couple is as it is. At this point it is as it is, 5 Newton meters. Hinge support, there will be one reactions. At roller support there will be one reactions. Hinge supports there will be two reactions, VA and HA. What about the distances? The distances here are 3 meters, 2 meters, this 2 meters has been converted to 1 meters, 1 meters, this as it is 2 meters, and 3 meters. So one by one we will find out the reactions. So again in the same pattern, in the same way, first we will take a moment. What are the different conditions? Fx is equals to 0, Fy and moment. So first condition we will take as Fx. So Fx is equals to 0, all horizontal forces is equals to 0. Therefore HA is the right side force plus 10 cos of 30 degrees, that is equals to 0. Therefore HA is equals to negative. Okay, right side is negative. The value of this 10 cos 30, it comes to be minus 8